Hi. Now what we have here is a question based on the Trapezium rule. And if you're not sure the Trapezium rule, you can always check out my tutorials on this on my website, ExamSolutions.net. Anyway, you might like to give this a go and pause the video, come back when ready, and I'll run through the work solution. Okay, welcome back if you had a go. So what we've got here is the equation y equals the root of all of 3 to the power x plus x. And first of all, we've got to complete the table below, giving the values of y to 3 decimal places. So all you've got to do is just substitute 0.5 and 0.75 for x into this equation. It's always a good idea though to check out one of these values, okay, just so that you know that everything's working okay. So if you were to put 0.25 for instance into your equation, check that you get 1.251 to 3 decimal places, then you'll know you're keying in the right values. Okay, well if you put 0.5 through, you should find that you get 1.494. And if you put 0.75 through, you should find you get 1.741. And that's if you round both these to 3 decimal places. Right, now for the next part, part B, we've got to use the Trapezium rule with all the values of y from your table to find an approximation for the value of this integral. The integral from 0 to 1 of the root of 3 to the power x plus x integrated with respect to x. And what we've got to do is show clearly how we obtained our answer. Now I'm assuming that you're familiar, as I say, with the Trapezium rule. Just as a brief reminder, I've got the rule here in words. I always like to have the formula in words rather than what you see generally in the formula books. Essentially, that the area under a graph, I'll just draw you a sketch in fact just to show you what's going on, but if you were to sketch this graph for instance, we'll just take our axes. We've got our y-axis, we've got our x-axis, and this particular graph, not that it really matters what graph we're dealing with, but this particular graph is going to look, say, something like this. And when we do an integral, especially like in this one from 0 to 1, let's just mark that in, from 0 to 1 say, then we're finding essentially the area under the graph. The area under the graph from 0 to x equals 1, this area here. And that area can be approximated by splitting it up into intervals. And we've got intervals here. We've got where x is 0, 0.25, 0.5, 0.75 and 1. So if we were to mark those intervals in, let's just mark those middle ones in here. This is the one where you've got 0.25. Next one is 0.5 and the next one is 0.75. All those intervals are meant to be the same width, not that my sketch clearly shows it. But the Trapezium rule is that the area under the graph is approximately the width of a strip divided by 2, and then you do the first height, which would be this height, plus twice the sum of the middle heights, that's twice the sum of all these green heights, plus the last height. Right? So when it comes to working out this integral then, let's just put it down. The integral from 0 to 1 of the root of all of 3 to the power x plus x integrated with respect to x, that corresponds to the area underneath this graph. By using the Trapezium rule, we can say that this is approximately then the same as the width of a strip, and we can see what the width of a strip is. They're all meant to be the same, and that would be 0.25 because this first x value here would be 0.25 and so on. They're all of width 0.25. So we've got 0.25 the width of a strip, we divide this by 2, and then we do a square bracket and we multiply this with the first height. That's this height here, the y value, which is 1. So put 1 there, and then we do plus twice the sum of the middle height, so it's going to be 2 times, and now we just work out the sum of all these heights that I've illustrated in green. They're the y values that we've got here, 1, 2, 3. So we've got 1.251 plus 1.494 plus 1.741. So that's twice the sum of the middle heights. And then it's plus the last height, this one here. And that had a height of 2. So we just put plus 2 there. Okay? All you've got to do, use your calculator then to work this out. When you do work it out, what you find that you get is 1.4965. Alright? So that's the trapezium rule. Nothing to it, I don't think. As I say, I always prefer the wordy version rather than the formula that they give in the formula book. And I always think it helps just to draw a little sketch graph. You don't really have to know what the graph looks like as such, but it just gives you an idea of what you're doing, especially when it comes to working out what the width of a strip is. Okay, very easy to see from here.